everyone, my name is Patricia Sinope, and in this video we are going to compute the inverse matrices by Gauss-Jordan elimination. So in this video we are going to cover the definition of the inverse of the matrix A and its examples in 2 by 2, 3 by 3, and 4 by 4 matrices with its corresponding problem exercises. And in the last part we have the summation of our topic. Here we have the definition of the A matrix flashed in your screen. And before we proceed, you have to have a knowledge on how to reduce row echelon form or the Gauss-Jordan reduction of the matrix. So with your knowledge, one of the practical application of that is to find the inverse of the matrix. Here we have the inverse of the matrix A. Now for the definition, we have an n by n A is invertible or non-singular. There exists an n by n matrix B such that AB is equals to BA equals to I sub n, where I sub n is the identity matrix of order n. The matrix B called the multiplicative inverse of A. A matrix that does not have an inverse is called non-invertible or singular. To refresh your knowledge, the reduced row echelon form in 3 by 3 is like this one, presented this one here. So the 3 by 3 has 1 0 0 0 1 0 0 0. So this is 3 columns, 3 rows, and 3 columns. So this is called 3 by 3. And it is in the reduced row echelon since it has an identity matrix. And for the 4 by 4 matrix, we have here. And as you can see, it also have a diagonal one here. And it's just the same with the identity matrix here. Okay? So I have now the examples for 2 by 2 matrix first. So let's get the inverse of this one. So to calculate the inverse of matrix using elementary row transformation, we have here the reduced row echelon form. We first take the augmented matrix of this one, like this, where I is the identity matrix whose order is the same as A. Then we apply the row operations to convert the left side into I. Then the matrix gets converted into I converted to like this. So we can have it like this. Since our coefficient matrix is like this, we'll have our augmented value to our identity matrix, which is like this. So you can see it has a diagonal one here. So in performing, we have to find the pivot first. The pivot here is 2. So we have to multiply 2 into row 2, which is this one. So we have here 2 or 3 plus 3 or 1. I mean R2, because we don't have any row 3 here, R2. Transform to R2. Negative 2 R2, which is negative 6 plus 3 R3. R1 is equal to negative 6 plus 6, we have 0. Negative 2 R2 times negative 2 is positive 4 plus R plus 3 R1, which is 4 plus 3 is equals to 7. And then negative 2 R2, we have 0 plus 3 R1, we have 3 here. Then negative 2 R2, which is negative 2 plus 0, we have negative 2. Copy the first row. As you can see, the pivot here, naka-reduce na siya into 0 ang ilalom niya. There's no above the pivot, so this okay na to dito sa column natin. So second column and then second row, we have the pivot of 7 here. So in order to have a 0 above the pivot, we will gonna have negative 7 R1 plus R2 transform to R2. I mean R1. So sorry, this goes here. So sorry, this is R1, so this goes here in the row 1. So negative 7 R1 is negative 14. I mean negative 14 R1 plus R0, which is 0, which we're gonna have negative 14 as our row 1 here. Negative 7 R1 is negative 7 plus R0, which is R2, which is will become 0. F is 0. Negative 7 times 1, which is negative 7 plus R2, we have 3 here. So negative 7 plus R2, we have negative 4. Negative 7 R1 will become 0, and then R2, we have here negative 2. Copy the second row, we have. Next, we have here negative 14. So since itong diagonal na itong problem here, so we have now negative 1 over 14 R1 to R1. And then this one here is 1, 7, R2 to R2. Negative 14 times negative 114 is 1. Negative 114, 0 still. And then this one, negative 4 times negative 14, the lowest term, we have 1, 7. Tama ba? Negative 1, 7 ba? Since it is... Okay. 2 pala. 2 over 7. Then we have here... Okay. Again, negative 2 times negative 1 over 14. We have 1 over 7, right? Then we have here 1, 7, which is still 0. This one, 1. So we have here 3 over 7. And then this one is negative 2 over 7. So this is the inverse of our example here. So we have the answer here as, what is that? A inverse is equals to 1, 0, 0, 1, 2 over 7, 3 over 7, 1 over 7, negative 2 over 7. Okay. So this is the answer. So you can see, ang inverse, nabalhin diri sa left side, and then nabalhin diri sa right side tong isa. So sorry, wala tayo naka-center. So this is the answer for this one. We have another example. Second example. So the answer for this one, we have A inverse is equals to 1, 0, 0, 1, negative 1, 3 over 2, 1, negative 1. As you can see, madali lang masyado pag 2 by 2. Now, have this as your problem exercise. Solve this at your own. And then I'm gonna flash the answer here. So the answer for the problem exercise 1, we have 18. Then answer for this one, we have A inverse. I'm so sorry, A inverse ito. Is equals to here. This is your answer. If you can get it, we can have it, our 3 by 3 examples now. We have a correction for our problem exercise answer. This one is not negative 1 over 18. This is only negative 1 over 8. Okay? Basta hindi lang ninyo makuha because it is my fault. So the answer is this one. Replace negative 1 over 18 to 1 over 18. So now let's move on to our 3 by 3 examples. Okay, are you guys excited? Now we have flash in our screen the 3 by 3 examples. Okay, yun yung mahaba-haba ito. So we have here negative 3, 6, 3, 2, negative 6, negative 4, negative 1, 7, and 4. So to form an augmented value here, we have not 0, 0, 1, 0, 0, 0, 1. For the augmented matrix. So, hindi natin pwede ma-reduce ito. So, we have to compute each para mahimo siya ganito. So, this is the answer. Negative 1/3 times negative 1/3, 1/3, 2/3, 1/4, 3/4, negative 5/4, 1/2, and negative 1/2. So, this is the final answer. No corrections na. So, this is the final answer of our first example. Our second example for 3 by 3 matrix, I'm gonna use the red pencil pen because I have naubos na aking the pen. So this is still in augmented matrix, and we have here 1, 1, negative 6, negative 1, 0, 2, 0, negative 1, 3. Then to make it an augmented matrix, so we're gonna have our identity matrix is already here. Okay, performing the pivot here is 1, so we have, I'm so sorry, so we have negative R2 plus R1 row 2. And then, since this is negative 6, so we're just going to multiply 6 to R1, then add 2 to 3. Okay, just copy the first row. Negative 1, 0, 1, 0, 0. Performing negative, we're going to multiply negative 1 to second row, then add the first row. So we're going to have this as 0, negative. So we have 0 here, and then add negative 1. Negative R2 will have positive 1, and then 1 here. Negative R2 is 0, then 1 here. Then negative R2 is negative 1, still 0. We perform 6 here. 6 plus negative 6 is 0. 6 negative 6 plus 2, we have negative 4. 6 times 0, 0. 1, 3 here. 6 still have here, and then 0, and this one is 1. Now our second pivot is negative 1. So we have to multiply negative 1 to R1, then add to R2 goes to R1. Now we have to multiply 4 R1, then add to R3 to transform row 3. Now we have negative R1 plus R2 is negative 1. Negative R1 is positive 1 plus R2 will become 0. Negative 1 times 0 is 0, then add 1. Then we have negative 1 plus 1 is 0. This is negative 1 times 1, we have 1. Then negative 1 plus R2, which is 1, so 0. Then we have here negative 1 and 0 here. Now let's copy the second row since nadali ang atong pivot. So we have here negative 4 times 1 is negative 4. Come it here. Negative 4 plus R3. Negative 4 R1 plus R2 pala to. Negative 4, so still 0. Negative 4 R1 will become positive 4 plus negative 4 is 0. And then negative 4 plus R2. Negative 4 R1 is 0. Then plus this is negative 4 R2. Negative 4 R1 plus okay. Then this is 3. This is 2. Okay, negative 4 R2 plus R3. Okay. Negative 4 R2 and positive 4. Okay, negative 4 times 1, we have negative 4 plus R3, we have negative 1. And then negative 4 times 1 is negative 4 plus R3, which is 6. So negative 4 plus 6, we have 2. Negative 4 times negative 1, we have 4 here. And then negative 4 is 0, then 1. Now our pivot here is negative 1. Performing the negative 1, so we have R1 plus R3, R1. And then R2 plus R3 to R2. So we have the following. R1 plus R3 is still negative 1. R1 plus R3 is 0. R1 plus R3 is 0. R1 plus R3 is 2. R1 plus R3 is 3. So 0 plus 1 is 1. So let's just have to add the third row, and second row. So 0, negative 1, 0. This one we have 3. This one we have 3. This one we have 1. This one we have 0, 0. This one we have 0. Oh, we're just gonna have to copy pala since wala man tayong i-perform dito. So negative 1 pala ito. I'm so sorry about that. 2, 4, and then 1. Now, negative 1 ito, so let's make that positive. How? We're gonna have to multiply negative 1 to R1. Or you can have this as like this. You put negative 1 here. It's just the same. Then we have here R3. So, performing this one to this one, and then this one, we have 1, 0, 0. This will become negative 2, negative 3, negative 1, 0, 1, 0, negative 3, negative 3, negative 1, and then 0, 0, 1, negative 2, negative 4, then negative 1. So this is our final answer for this one. So the inverse of this one is, so the inverse of our solution here is this one. 1, 0, 0, 0, 1, 0, 0, 0, 1. Then negative 2, negative 3, negative 1, then negative 3, negative 3, negative 1, negative 2, negative 4, then negative 1. So for our two examples here, we have the following answers. So let's move on to our problem exercises. Okay. Now we have our problem exercises here, and you have to answer this on your own before you check the answer in here. I'm just gonna write the answer for checking purposes. So here we have to, this is the linear equation, we have to transform this into matrix. So for coefficient matrix here we have 2, 3, 2, and then 3, 3, 4, and then 1, 1, 1. So since we are finding the inverse of our given matrix here, we have to have the augmented value here as our identity matrix. Looks like this. So the answer for this is 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, and then negative 1, negative 1, 6, 1, 0, negative 2, 0, 1, negative 3. So this is the answer for this problem exercise here. Now the answer for the second exercise, we have it here. So remember, you have to look the answer here for checking purposes. Okay, so this is the answer, negative 11 over 12, negative 1 over 6, 3 over 4, 1 over 3, 1 over 3, negative 1 over 3, 1 over 12, negative 1 over 6, and 1 over 12. So this is the answer for the second problem exercise. You just have to perform it on your own, then check the answer for checking. Okay, we are done with the examples and problem exercise for 2x2 and 3x3 matrix and finding the inverse of the matrix A. Next we have here your problem exercise. You have to get how this A matrix here become to A inverse here using the identity matrix by Gaussian elimination. So you have to perform the following, then come up with the same answer here. So it might be difficult to you, but it's the same process. Find the pivot. After you find the pivot, reduce it into 0 the numbers above and below the pivot. So for example, we have here 2, or pivot here is 2, then you have to reduce the numbers below this one into 0. And you have to manipulate the matrix in order for you to get the inverse of A. So that's it for our video today. Again, this video is about computing inverse matrices using the Gauss-Jordan elimination. And again, I am Patricia Sinalpe, and I hope you learned something from this. Bye!